Welcome to the ET-197 lecture video on relays. Here I'm showing a diagram of a relay, a normally open, unpowered relay. And what we have here is a coil. It's a coil of wire that we are going to energize, and it's going to produce a magnetic field, which is going to pull down the contact and closes contact when we're powered. Okay, so this is a standard cross section. So we have the input circuit, a battery, a switch, and a little lamp to tell us that the switch has been pressed. This is low current. This side is high current. That's the reason we use relays, so that we could have a small signal in and we could provide a large amount of current on the output. Okay, so normally open means with no power, the contacts are open and there's no current flow. Here I'm showing a normally open contact, but it's powered. We push our little button here, our switch. We have current flow through this circuit, which provides a magnetism. Our lamp will turn on, and our contacts are going to close. Now that our contacts are closed, we're going to get current flow through our lamp and our battery. So we're going to put a little bit of current here on this switch, and we're going to get a larger current output from a separate circuit, and the light will be on. Here we have a normally closed contact, unpowered. So our switch is open and we have no current to our coil. Since this is a closed contact, the contacts are closed, meaning that we have current flow. Our lamp is going to light and we're going to get current flow through this circuit. So this would be a normally closed, meaning with no power on the input circuit, we're going to get power on the output. Here we're showing a normally closed contact, powered. So what happens is we push our switch here, we get current flow through here, we get a magnet, and then the mechanism inside the relay forces the contacts open. Okay, so now we have no current flow in here. We have an open circuit. Here I'm showing a combinational relay that has an open set of contacts and closed set of contacts in the same box, essentially. And it is unpowered, so we have no magnetic field. And we have the open set of contacts with no current flow. The lamp will be off. Here the closed contacts are touching and we have current flow, and this lamp will be on. So this is the typical what we have in most modern relays, is we have a set of closed and open contacts in the same box, and most of these relays have multiple combinations of these open closed pairs. Here I have a diagram of a combination relay powered. So our switch is pressed, we have current flow here, so we have magnetic field which pulls our contact closed and opens up the other set of contacts. So here we have current flow in the open set of contacts, normally open, and our normally closed contact is now open and our lamp is off. Here I'm showing our combinational relay, how it would look in a ladder diagram. This one is a ladder diagram. As you can see, it looks like a ladder, and we have two lines. This is the power, typically, and this would be the ground, or if it's AC, this would be the neutral line. And the first line we have here, what we call a rung, the first rung, we have our push button and we have CR1. This represents this push button switch, and this coil. CR1 is the coil that activates our contacts. Okay, so here it's not pressed and no current. Okay, here's our second rung. We have CR1, and where it says our contact 1, this is a normally open contact in our relay, and this one is our pilot light. Okay, so CR1's our open contact, which will be this pair. This is our pilot light 1. Here's our third rung. CR1 is a different set. It's our close contact, and you can see here this would be terminal 2 on our wiring, and pilot light 2. And here, since it's not energized, our close contact is closed and we have current flow through here. So this is a ladder diagram that we'll be using, and this relay is used in logic. So typically logic relays are lower current than relay that would be used to drive a motor or something. So we'll use a logic, usually lower voltage, and then we'll have another set of circuitry relays to drive the heavy duty high current machinery.